For this problem, I am going to find the minimum or maximum value of this function. I'm going to describe the domain and range of the function and where the function is increasing and where it's decreasing. So first off, I need to find some more information about this because I need to be able to do it without a calculator. So the way I'm going to do that is I'm going to go ahead and I'm going to find A, B, and I'm going to find C. And I know that the x value of the line of symmetry is x equals negative b over 2a. So I'm going to go ahead and calculate that. So negative 18 over 2 times 3, which is going to be negative 18 over 6, which is negative 3. So I know that the axis of symmetry is at negative 3. Okay. I also know that the C value is also my y-intercept. So C is 5, negative 5. So I'm going to have a point at 0, negative 5. That's going to be where it crosses down below on the y-axis. Okay, so now what I have to figure out is if I'm dealing with a minimum or a maximum. So look at the A value. The A value is positive 3. That means it's flipped up and we're dealing with a minimum. So let's draw what we know so far. Okay, so far we know that there is a line of symmetry at x equals negative 3. So that's right here. We know that there is a point on this graph at c equals 0, negative 5, right there. And since we know that that's the line of symmetry, we also can count over from here and draw the symmetrical point to it. What we need to know is where is the y value of the vertex. So we have the x value of the vertex, so we just need to plug this negative 3 in to figure out what the y value is. So here I am, I'm going to do f of negative 3, which is going to be 3 times negative 3 squared plus 18 times negative 3 minus 5. So that's going to be 9 times 3 is 27 minus, let's see, 18 times 3. That's negative 54. And then minus 5. So then I'm going to have 27 minus 5 is 22. And negative 54 plus 22 is going to be negative 32. So that is my y value. My x value is negative 3. So this is going to go way lower. That means I'm going to have a minimum down there at negative 3, negative 32. So this is going to be really hard to graph. So we're just going to have to visualize that, okay? That negative 3, negative 32 is going to be way down here, right? So I'm going to be looking at a graph that does something like this. See if I can go any further lower. And it's going to have a vertex at negative 3, comma negative 32. And it's got these 2 points here, right? So I'm looking at what the graph looks like right now. So what I need to do is describe. So we're going to have a minimum value. The minimum value is negative 3, comma negative 32. We are going to have a domain and range. So let's think about our domain and range here. At negative 3, comma negative 32, below that, there are no more values on the graph because that is the minimum. So everything above negative 32, every y value above it will be included, and negative 32 will be. So for my range, it's all y values greater than negative 32. Okay? For my domain, if I were to squish this, compress it to the x-axis, these arrows right here would keep going forever and ever and ever. So my domain is all real numbers. Okay. And then finally, where is the function increasing and where is it decreasing? When it is decreasing, that is all the x values to the left of the axis of symmetry. So we would say it's decreasing here, right? It decreases to the left of the point negative 3, the x value of negative 3, and it increases to the right of x equals negative 3. So that's how we would do that. Okay, y'all have a great day.